Today we will learn about regression models. Regression models differentiated. A comparative analysis of linear and logistic regression and their optimization via gradient descent. Core model difference between linear regression and logistic regression. Understanding the fundamental mathematical and application distinction between the two algorithms. Task and hypothesis function. Linear regression predicts continuous variables, for example price. Hypothesis is a linear function of features. Logistic regression classifies binary outcomes 0 or 1, applies the sigmoid logistic function. Formula for both linear and logistic regression are given here. And for better understanding of both linear regression and logistic regression, you can see the diagram. Output range and parameters in linear regression and logistic regression. In linear regression, the model output range is minus infinity to plus infinity. The parameters represent the magnitude and direction of the relationship between each feature and target value. In logistic regression, the model output range is 0 to 1, interpreted as a probability. The parameters are weights that control the shape and position of the sigmoid curve, determining the probability of the positive class. The cost function for linear regression and logistic regression. Linear regression. Mean squared error measures the average squared difference between predicted and actual values. This function is convex. Logistic regression. Log loss. Cross entropy. Penalizes the model heavily when it is confident about an incorrect probability prediction. This function is also convex. Formula for both mean squared error and cross entropy is given. Optimization is done by gradient descent. It is a universal algorithm for iteratively minimizing the cost function. The gradient descent mechanism. The updated rule. The algorithm finds the optimal parameters by repeatedly taking steps proportional to the negative of the gradient of the cost function. Formula is given here. Gradient descent's role in both models. In linear regression, because the MSE cost function is convex, gradient descent is guaranteed to converge to the global minimum, providing the single best set of parameters. In logistic regression, the use of the log loss cost function ensures that the optimization landscape remains convex, enabling GD to reliably find the global minimum without getting stuck. The convergence. In both models, gradient descent works by iteratively finding the direction of the steepest descent, the negative gradient, to efficiently update parameters toward the minimum cost. Thank you guys for watching. If you have any questions, please comment down below.